Good day, everyone. My name is Andrea Jane F. Innocente, and I'm gonna discuss my topic that is intermolecular forces. So, first, what is intermolecular forces? So, intermolecular forces is the term intermolecular forces is used to describe the forces used to describe the forces of attraction between the atoms, molecules, and ions when they are close to each other. It means that ang intermolecular forces is nag-attract na siya between the molecules. So when two particles experience an intermolecular forces, a positive charges on one particle is attracted to the negative on the other particles. When intermolecular forces are strong, the atoms, molecules, or ions are strongly attracted to each other and draw close together. These are more likely be found in condensed states such as a liquid or solid. When intermolecular forces are weak, the atoms and molecules or ions do not have a strong attraction for each other and move far apart. I'm gonna describe each type of the intermolecular forces of attraction, and it consists of the ion dipole interaction, hydrogen bonding, London dispersion forces or LDF, and dipole-dipole interaction. So the first is the ion dipole interaction. So ion dipole interaction is interaction between a charged particle called ion, which can be positively charged cation or a negatively charged anion, and apolar. This exhibited in a hydration or the interaction of water with the cations and an ions of ionic compound dissolved in water. When sodium chlorine dissolved in water, sodium chlorine will dissociate into sodium cations and chlorine anions. Because the water is a polar molecule and has a partially negative part and partial positive poles, the sodium will form an ion dipole interaction with the partial negative part of the water molecule, and while the chlorine negative will form an ion dipole interaction with the partial positive part of the molecule. So, positive man ang sodium, ma-interact jud siya sa partial negative dito sa water molecule. And sa katong chlorine negative, it is ma-attract jud siya dito sa partial negative dito sa water molecule. To sum up, the ion force exists in the attraction between an ion and a dipole molecule. An ion is charged atom because it has gained or lose one or more electrons. It can be either positively charged cation or negatively charged anion. The partial charges at the end of the dipole molecules make an ion dipole interaction. The next one is the hydrogen bonding. So, the hydrogen bonding is when a hydrogen atom is very covalently bonded to nitrogen, oxygen, or fluorine. A very strong dipole is formed. So, ang example na ato sa katong hydrogen bonding kay katong nitrogen, oxygen, and chlorine. Mo nang usually nga kuan sa hydrogen bonding. The dipole-dipole interaction that results from this dipole is known as the hydrogen bonding. Hydrogen bonding is a special strong form of a dipole interaction. I said that the hydrogen bonding is a special type of a dipole-dipole interaction between the hydrogen atom in a polar molecule and the highly electronegative atoms like the oxygen, fluorine, nitrogen, and other molecule. So the electronegative atoms like the oxygen cause the bond to be polar. This atom becomes slightly negative charge and the hydrogen atom becomes slightly positive charge. Thus a dipole exists. The hydrogen bonding is an attraction between a partial positively hydrogen in a polar molecule and a slightly negative atom in the partial and a slightly negative in another molecule. For the next one is the London dispersion force. So the London dispersion force, or the LDF, exists for all substances whether composed of a polar or a non-polar molecules. LDF arise from the formation of a temporary instantaneous polarities across a molecule from the circulation of the electrons. So an instantaneous polarity in one molecule may induce an opposing polarity in adjacent molecule, resulting in a series of attractive forces among neighboring molecules. Molecules with higher molecular weight have more electrons. These make their electron clouds more deformable from nearby charges, and a characteristic called polarizability. As a result, molecules with higher molecular weight have a higher LDF and consequently have a higher melting point, boiling point, and the enthalpies of vaporization. So, for kani example is like kanang let's say nga naay duha ka neutral atoms na neutron and protons nga nasa tunga, and ang gasurround ato is the electrons. So since neutral man sila, unsaon nila pagka na ay kanang paano sila nagkakaroon ng forces of attraction o paano sila nag-attract sa isa't isa kahit hindi sila dipole. So ang electron at molecules, ang manggod kay ang electron ug molecules kay they don't stay in one place or one spot lang, but they move around, and sometimes because sa ilang kaliyukan ang mga electron, ang mga uban sa ilaha is maadto sa ubang side habang nahitabo to nagiging slightly negative ang kabilang side, at sa ubang side naman kay nahimo na sa slag slightly negative, kaya mo ginatawag na to og instantaneous dipole. Pero dili siya permanent na ganyan. Pag nagkakaroon ng kanang instantaneous dipole, ito molecule na ito mga kalabing nucleus niya ay mapapansin na magiging slightly negative na siya sa isang sa side, and that would cause a reaction, and because of the reaction nagkakaroon na sila ng instantaneous dipole. Ngayon ang mga positive side ay na-attract sa negative side. Ang nagpapa-attract sa kanila kaya ang tinatawag na London dispersion forces. So, tsaka ang London dispersion forces ang pinakamahina sa intermolecular forces of attraction. Isa ring reason dito ay hindi naman permanent ang, as I said nga, dili permanent ang instantaneous dipole. Ang nagpakusura, ang napalakas lang sa dipole, ay napalakas lang sa London dispersion forces ay nakadepende sa kadaghan sa electrons niya. Next is the dipole-dipole interaction. So the dipole-dipole interaction exists between the molecules that are polar, those that have a permanent dipole moment due to the uneven sharing of electrons. This uneven sharing gives one side of the molecule as a partial positive charge, and the other side is partially negative charge. The polarities of the individual molecules tend to align by opposites, drawing molecules together and thereby favoring a condensed space. Substances with dipole-dipole interaction tend to have a higher melting points and boiling points compared to non-polar molecules which only have LDF. In this type of intermolecular force of attraction, dito papasok ang importansya ng polarity. Dahil tandaan, ang mga polar molecules lang ang nagkaka-experience ng dipole-dipole forces. Yung mga non-polar molecules hindi, for the simple reason na walang dipole ang mga non-polar molecules. For example is oxygen molecule that we inhale. Bilang non-polar molecule siya, evenly distributed ang mga electron niya. Wala siyang dipole. Samantalang itong water molecule na polar siya, samantalang itong water molecules na polar molecule, hindi evenly distributed ang mga electrons niya, kaya may part na slightly negative at may part na slightly positive. Therefore, meron siyang dipole. Kaya nga, ang mga polar molecules na katulad ng water ay nakaka-experience ng dipole-dipole forces. Simple lang ang nangyayari dito. Yung mga partial na slightly negative ay na-attract sa partial na may slightly negative. Ito yung dipole-dipole force. Itong dipole-dipole force ang dahilan sa likod ng mga special properties ng water, at isa dito ang surface water. Diba, when you, let's say, karayom, imong slowly kanang ibutang bitaw siya sa surface sa water, kay diba, kay di man siya mulugdang, kay is because of the surface tension. So if mulantaw ka closely sa water molecules, makita nimo nga katong partial negative, ang partial negative dito sa, di ba, example lang tawon nimo tong closely lang tawon nimo tong water molecule, kay makita nimo tong sila nga katong slightly partially positive sa sa water molecule, o sa isa ka water molecule nga slightly partially negative ang yang side, kay mag-interact dito sila. So mara sila digkit kaayo bantog nag-cause siya og bantog mao tong surface, mara bantog na ay surface tension. So, the dipole-dipole dipole-dipole interaction is that all polar molecules have a partial negative and partial positive end which are attracted to each other. The resulting forces are called the dipole-dipole force or dipole-dipole force are much weaker than the ionic or covalent bond.